That would be very nice. Yep. For
Cool.
those of you who don't know, Sneh is from the LW3 team, and it's an honor that she joined us today.
No, I think what you guys are doing is really, really amazing. Yeah,
Thank
I
you.
really support this.
Yeah, it was actually Sneh who texted us and said that if you guys wanna teach Solidity, and we said yes. Okay, so it's time now. Let's start today's session. Thank you all for joining. I hope you all are having a good day. Before we start, I want to say that I would advise you to code along with me. Just code along whatever I'm doing, so that way you will have a better understanding of what's going on. Also, if you guys have any questions, you can just stop me in the middle and ask me questions. And I am no expert at this. I am also learning along the way. There might be topics that I don't understand, so we can figure it out together, right? All right, so as promised yesterday, first of all, I am going to be explaining very briefly like how blockchains work, because I think it's very important for every one of you to understand this, because when you will deploy your smart contracts or you will do transactions, you can see the transaction hash, and there it will say it is included in block number this, right? And you might not understand what is this block number and everything. So I am just going to be explaining how blockchains work very briefly. Okay, so let me just share my screen. Tell me if you guys can see it.
Sai,
LJ? Yes.
Yeah, yeah,
it's
I can
good.
see it.
Your screen is good.
I can see it.
All right. So LJ, just start the recording of today's session. Um,
I got it.
Let me just go to my Jamboard so that I can better. Okay, let me just outline what we are going to do today. First of all, I'm just going to briefly explain in 5 minutes how blockchains work. Right? It's going to be a very brief explanation. If you want to know in depth, so I will link to a course. It's by blockchain at Berkeley, so you can know how blockchains work exactly from that course, but I'm going to explain it briefly. And after that, we are going to write a simple storage smart contract. We are going to store some data onto the blockchain, right? And we are also going to retrieve it from the blockchain. Okay, and then after that we are going to understand why is it important, like why is it useful to store data on the blockchain. It can act as a proof of ownership, right? So we are also going to do that. You will understand more as we go. Okay, so let's start with the blockchain basics now. Let me create another Jamboard file. Have you ever wondered how new tokens are created? For example, how new bitcoins are created, or how new Ethereums are created or minted. Minted is the term for that. That is through the process of mining, right? And let me just show it to you guys. So, for example, let's say there are three people. Okay, in for this example, for you all to okay, have I stopped my screen sharing, or is it visible? LJ?
It's visible. You good?
Okay, okay, cool. So for you guys to for the sake of explaining it to you guys, let's take the example of Bitcoin blockchain. All right. So let's say there are three people. There is Bob, and there is Alice, and there is another one. Let's say John. All right. This is Bob. This is Alice, and this is John. Let's say we have these three people on the Bitcoin blockchain. Now Bob comes in and he transfers. Uh, 1 Bitcoin to Alice, alright, 1 BTC, and then Alice transfers for some reason 2 Bitcoins to John. Okay, and then John transfers 3 Bitcoins to Bob again. So as soon as they transfer the bitcoins, uh, the transactions are not confirmed instantly. Actually, they will be unconfirmed at that time. You can go to this website called blockchain.com/explorer. Now this website allows us to like know the current state of Bitcoin blockchain, because we have selected Bitcoin here. So you can see here, these are the latest transactions that are happening on the Bitcoin blockchain right now. Okay, and these are unconfirmed. You can see the most recently published unconfirmed transactions, right? They are not included in any block right now. These are unconfirmed, right? These are happening in real time. So what will happen is the Bitcoin blockchain produces a number which is called nonce, right? And this number is like it's a long number, and would be something like OX and something like that. Okay, and this the number would be something like this. So what happens is there are miners in our network. Okay, let's say we have three miners in our network: miner 1, miner 2, and miner 3. Okay, now these people, the miners, they have the whole history of all the transactions that happened in our Bitcoin blockchain, right? And what they do is they help us to run our blockchain. So what will happen is these three miners will guess what this number could be, this nonce could be. Okay, they already know how much bytes this number is long, right? They know certain properties about this number, and they will just guess what this number could be, right? And they just do this by hit and trial method. All three of them will just try to guess what this number could be, which is generated by our Bitcoin blockchain. And once any of them finds that number, let's say miner 3 found that number, that it was this number which was generated by our Bitcoin blockchain, then what will happen is it will just record all these transactions that happened, right? It will record that Bob transferred one Bitcoin to Alice, and Alice transferred 2 Bitcoin to John, and John transferred 3 Bitcoin to Bob, right? It will record these transaction miner 3, and once this miner finds this number, freshly minted 6.25 bitcoins will be given to this miner, because that's how Bitcoin blockchain works. Okay, so 6.25 bitcoins will be transferred to this miner 3, and it will record those transactions, and then uh, it will just it will let other miners know that these transactions happened, and then they will verify those transactions that yes, really Bob transferred Bitcoin to Alice, and Alice to John, and John to Bob. They will verify those transactions, and they will store it in their local ledger, right? And that's how this all works. Okay, it will be, those transactions will be included in a block. Okay, so every 10 minutes a new block is generated approximately. So those transactions will be included in a block, and that means they are stored in our blockchain. Right now these transactions are unconfirmed, and these are our blocks, and these blocks contains our transactions. Okay, so that's how it works briefly. Okay.
Sahil, I wanted to ask something.
Yes.
Yeah, you described that nonce is that number. So what is that? Is that the unconfirmed transactions? Like, what is
No,
that?
no, no.
Yeah.
Nonce is it's just a random number generated by the Bitcoin blockchain, right? It's generated by Bitcoin blockchain and guessed by our miners. These miners will guess what that number could be, and the miner that will actually guess the right number will get the block reward. Okay, those are not the unconfirmed transactions.
So
Yeah, and
like why is it
yeah,
you
something
can
else I want to point out too. When you are mining, miners they use this hardware. They use very expensive hardware, and they use a lot of electricity, and they use this hardware to basically run these calculations, run these algorithms, and this hardware equipment it basically uses electricity to try and obtain that nonce, and once it obtains that nonce, then it it is able to like confirm that transaction. So that's basically what it is. These miners they try to use their hardware to figure out the nonce, and that way they can confirm the transaction and put it on the blockchain.
Yeah. Also, they get a block reward for finding that nonce.
Yes,
So
I do understand what is happening. But what is nonce like? I'm not getting. Like, why do we need to break that code? Like, what is nonce? The hardware is.
so yeah,
What is that
good
code? Like, what
question.
is the definition of nonce? Like, I got. Yeah.
So basically, it's just a random number. Okay. Now let me give you an example. Let's say there is me, you, and LJ in the network, and I come in and let's say I am also minor, and I come in and I say you transferred 6 bitcoins to me. Okay, I cannot say that random. Firstly, I have to guess that random number. Not I have to guess. Only then I can say that yes, you transferred that much bitcoins to me. But like let's say you did not transfer those bitcoins to me actually, but I am lying that yes, you did transfer those to me. So for me to lie, I have to break that code. I have to do that amount of work to guess what that random number was, right? I have to do the work and then I can lie. And even after that, those transactions will be verified by other miners, and they will know that yes, I am lying because that transaction did not happen. So ultimately I wasted my resources, right? I tried to guess that number. I tried to guess that nonce, but I was not able to guess it. Sorry, I guessed it and then I lied, but still I was not able to like hack the system, if you are getting what I'm saying.
Yeah,
So
yeah.
it's basically, if we did not have norms, then anyone can come in and say, yes, you transferred that much Bitcoin to me, and you transferred that much Bitcoin to me. Right? They can come in and they can actually like they can fool the network. For for even to for even them to lie, they have to do some amount of work. So that discourages them to lie, right? Like it's
Yeah.
totally okay if you are not totally understanding it. Actually there are courses for you can look at those courses.
Yes, yes, I get it. Yeah, you can make
Blockchain
those.
at Berkeley, they have very good courses about how blockchain works. Now, it is a huge topic. Like, there are two courses created by this blockchain at Berkeley on how this actually works. So, first one is this Bitcoin and cryptocurrencies, and the second one is blockchain technology. Now, these are like 12 hours of content, and I am trying to explain it to you in 5 minutes, right? So, of
Um,
course, there are things
Yeah,
that you
can
might
I
not
like
understand.
can I a little bit add to what
Yeah, yeah, yeah,
Anon
sure,
said?
sure, sure. Please go ahead.
Yeah. So I think Rahul asked this question. So you know what a block is, right? So block has some transactions. It has a timestamp. It has like other information which depends based on the chain. So like ETH has different kind of information on its blockchain, and Bitcoin has other kind of data on its block. So like every chain has a different data on the block. But there is some data which is constant. So like for Bitcoin, the previous block hash, the timestamp, uh, some things that are like common. So what how nonce is calculated is um, you take a you hash all this information which is like common. So like for example timestamp, the data inside the block, the previous block hash. So you hash all this along with a random value to achieve a certain level of difficulty, and this difficulty is keeps changing based on how the blockchain is progressing, right? So if there are lots of nodes in the system, the difficulty has to be increased. But if there are very few nodes, you decrease the difficulty. So difficulty keeps changing. But what you basically do is you hash all this information along with the nonce and make sure that you keep trying different kinds of random values. You keep trying different kinds of nonces until and unless you satisfy that difficulty. And in layman terms, how people explain this is until you achieve certain numbers of zeros in front of the hash, but that's not actually true. But I'll give you an example, right? So, like for example, the difficulty of the system is such that you need 7 zeros in front of your hash, right? But that's not always the case. Consider this as an example. Difficulty keeps changing. But for example, right now, for you to achieve the difficulty, you need 7 zeros in front of your hash. So you'll hash all this information that's already in your block along with a random number of nonce, which you have to compute until you get that 7 zeros. And the first person who gets that 7 zeros along with a nonce is able to publish the block to the blockchain. And that's what nonce is used for. It's right you because the other information is common to everyone, right? The only thing that's not common, and that's what you have to put your work for, is the nonce. Um, I'm not sure if that makes
Thank you.
sense.
I have a question. So, is there more than one nonce that could solve the difficulty?
Uh, yeah, so there is more than one nonce because the miner can choose the transactions that he wants to put in a block from the miner pool. So yeah, so for example, there are two transactions which give you the same amount of money. It's up to the miner which blocks they want to include in the transaction, and based on those transactions, you would have to calculate a different nonce. And yeah, if you meet the difficulty, the block gets in.
Thank you.
Yeah, and the miners generally select those transactions which have higher transaction fee because they will get that a certain amount of that fee, right? So they select those transactions which have higher transaction fee. They include those transactions first in the block. Thank you, Sneh, for clarifying it a bit further. And don't worry if you don't understand anything about this. Because for the coding part, for coding Solidity, you don't need to know very in depth about this. It was just a brief overview of what it is, and also for the Ethereum blockchain, the block time is approximately 15 seconds. For Bitcoin, we have 10 minutes, right? So a new block is generated on Ethereum blockchain every 15 minutes. So every 15 seconds, I'm sorry. Now let's head over to our remix and uh, let's create another Solidity file here. We are going to create a simple storage smart contract, right? So let's call it simple storage. And as LJ told yesterday, that we have to specify a license in the first line. So let me just specify that identifier, that's going to be MIT. So what we are saying here is that this code is MIT licensed. That means anyone can use it for uh, anyone can use it in their projects, even in personal projects or commercial projects, right? So this code can be used by anyone. If you don't want your code to be used by anyone else, you can just say unlicensed. Sorry, unlicensed. So then it restricts anyone to use your code. But I want you guys to use it as you want. So I'm gonna say MIT. After that, we have to specify the compiler version. So we are going to use 0.8.4. Okay, sorry. So it's gonna just pick the latest the version higher than 0.4, right? The latest version higher than 0.8.4. And then we have the contract keyword to just define a contract, right? To create a new contract, we use the contract keyword. And after that, we write the name of the smart contract. So this time we are going to create a simple storage, right? So this is the name of our smart contract. Now we want to store something on our blockchain. Okay. Now let's say it is a number. And for numbers, we have the data type of uint. Now uint is basically a data type, and what it means is that uint data types can only store values which are either 0 or greater than 0. Okay, it cannot store negative values. The values can only be positive. And we are also going to have a dedicated day when we are also going to cover all the data types. But for now, just know that this value can only be greater than or equal to 0. So let's create a uint data type, call it stored data. Stored data. Okay. And let's say the number is 5. All right. Now what we are going to do is this is our data that is stored on the blockchain. Okay. Now we also need to fetch it. And for fetching this data, we have to create a function, right? So just create a function. Now functions are basically reusable pieces of code. Let me just write it and then explain it to you. Now this is a function and let's call it get stored data. And let me just type it out real quick and then I will explain it to you. So yeah, let's see. The functions are reusable pieces of code. That means whenever we will call this function get stored data, it will just run the code inside. It will run the code inside these curly braces. So every time we call this function get stored data. Okay, so this is how we define a function using function keyword, and this is the name of our function, which is get stored data, right? And in these parentheses we put parameters if this function accepts any parameters. We'll tell you more about parameters right now when we'll create a function to set this data. Okay, and public means it can be called from outside the from our smart contract, from outside of our smart contract. Okay, I'll also show you what I mean by this right now. Okay, view means it does not do it does not change anything on the blockchain. It's just returning the values already stored on the blockchain. That's what view means. And returns is we have to specify what this function will return, and this will return a uint value, right? It's uint stored data, so that's why we are saying it returns a uint. Okay, let's compile this contract. Okay, it is compiled and the version is 2.7 we have selected here. Alright, now we come to this app. It's called deployed app, right? And we have selected JavaScript VM. Now let's deploy this contract. And we can see the deployed contract here. Okay, now you see we have get stored data here in our smart contract. Now why we are seeing this get stored data? Because it was a public function. Was it not public? If it was not public, then we would not be able to see this here, get stored data. That means it cannot be called from our smart contract, from outside of our smart contract. Right? So when I click this get stored data, it gives me 5, right? Because 5 is the value of our stored data. Actually, I misread it. It is stored data. Right. So this gives us the value of stored data, which is 5. But right now it's useless, right? We
I'm
cannot
sorry,
change this value or anything. Yes.
you are lagging a little bit. Is
Oops.
it me
I
or is
guess it's my.
Yeah, he's been lagging a lot, so maybe there's a way
yeah?
to increase the connection.
Oh yeah, it says red. Give me a second. Sahil, join the other pair programming channel. I'm gonna drag everyone in a second.
Okay.
You join first so that you can like the server. We're gonna wait for a second so that he gets the server. That's how Discord works. Yeah. Yes. Start dragging people.
Bro. Yeah, let's go.
Dragging seems fun to do.
Yeah. Still, what about now?
Let me try to share my screen.
Okay, it looks like it's sounding better.
Can you see my screen?
Yes.
Not yet. Probably.
Yeah.
Okay, yeah, you're
Better
good.
now.
You're good.
Is it still lagging?
No,
Not yet.
you're good.
Okay.
You're good.
So we have our simple storage smart contract, and we have this get stored data function, and it gives us 5 each time we press this, right? But let's say I also want to change what this data is, right? So we'll create another function for changing this data. Let's create a function called set stored data, okay? And it will take a parameter or argument, you can say. Now, what a parameter or an argument is, it's basically the thing that we will pass this function. We will say we will pass a integer to this function, and we'll say set the value of stored data to this integer, right? So it will take an argument which is also going to be a uint, and let's call this uint x, right? And then it's going to be a public function, right? And what it's gonna do is it's just gonna set store data to x, the value that we pass to this function. That's all it's going to do. All right, now let's compile this smart contract and deploy it again. Now when we deployed it, now we can see another function here which is called set store data. Okay, now if I press get store data here, you can see it is 5 right now. Okay, but I also want to set this data, so I can come to this function called set store data, and let's set this to 10. Okay, and then I will say set store data, and you can see the transaction went through. It was also some amount of gas was used in this transaction, because we had to change something which was stored on the blockchain, right? We had to change the value of stored data. It was stored on the blockchain, so it used some gas. You can also see how much gas was used, right? Transaction cost, execution cost. So the transaction went through, and now if I call this function get
Is
stored data,
Sahil lagging?
you can see
Or
it is 10.
you are lagging, Sahil, I guess.
Is it too much?
It's okay now.
Sorry about that. So you can see it is 10 now. Let's change this to 105, and the transaction went through. Now if I click here again, it is 105 again, right? So now we are also able to set a value and also get a value from the blockchain. Now you might ask, but oh, Sahil, why is this useful? Why do we want to store something on the blockchain, right? So the answer is it also acts as a proof of ownership, right? Because let's say you wrote a poem, and you want the world to know that yes, you wrote that poem, and you wrote that poem on that day. Or let's say you discover something, you created a formula for something, the next E is equal to mc square, right? And you want to prove the world that you were the one who who discovered that formula, right? So what you will do is you will create a smart contract, and you will put all those information in that smart contract and deploy it to the actual blockchain, right? It will give you the link to that transaction, to that smart contract, and you can prove to the world yes that it was you, right? Let me just show it to you guys in practical. Okay, let's create another file called my poem. Okay, so let's say I wrote a poem and I want the world to know that it was me who created that, who wrote that poem at that time. So I'll just copy paste this license and the compiler version here. Now let's create another contract called my poem, right? Now we need strings here, right? We need to store our poem, and we also need to store the owner, which is me. Let me see if it is working fine. Am I still lagging or is it fine?
No, you're good. You're good.
Okay. So we need to store our poem in this smart contract, and also we need to store the information about ourselves. Okay. So let's create a string data type here. String basically means um, just array of characters, right? Like A, B, C, D, something. Strings are arrays of characters. So you can write anything in between strings. String is data type. Let's call this let's call this string poem. Okay, and now you can write anything here, right? The your poem. You can write your poem inside this.
Yeah,
So
just
let's see.
let us know.
Yes,
Like the camel case thing is not necessary in contract name.
in contract name. No, I guess it's like it's not necessary, but I guess it is always a capital letter. The first letter is capital in the contract name, if I'm not
A
wrong.
good practice. Yeah. Yeah.
Yeah, the first letter is uppercase for the smart contract,
Yeah.
and yeah. So we can write our poem here. Let's say I wrote a poem, Johnny, Johnny, yes, Papa, mm, right? Whatever, and then we are going to create another string for the information of the writer, right? Let's say I am the writer, or let's call it poet of this poem, and then what I will say here, I am Sahil and I wrote this poem on 22nd of March 2022. Okay, whatever. So now you don't want anyone to change these values, right? You don't want anyone to change the poem or change the details about the poet of the poem. So we are not going to create a function to set these values. These will be hard coded in our smart contract, and these will stay like that forever. Okay. So we are just going to create a function to get these values, right? To get the poem and to get the poet. So let's create a function for get details. Okay, and it will be a public function. That means we can call it from outside of our smart contract, and it will be a view function because we are just returning something. We are not we are not changing anything on the blockchain, right? We are just returning some data from the blockchain. That's why it is a view function, and it returns. Now, this might confuse you a bit, but just bear with me. Um, it's gonna return the poet and the poem. Now, what you might be thinking, what is this, right? So we are saying that it returns two strings. The first ones, sorry, it is going to return two strings, this one and this one. Now you might be thinking, what is this memory, right? Uh, so memory is the location where we want to store those strings, because in Solidity we have different memory locations. We have a state variables which are stored in permanent memory, right, which is called storage. And we have memory which is kind of like a temporary memory. It will be just stored for the sake of this function call. Think of it like your computer has a ROM, which is your hard disk storage, right? And data stored on the ROM will be stored forever there, right? Unless and until you delete it, uh, right? But you cannot delete it on the blockchain. But and your computer also has a RAM, which is random access memory, which is just temporary. All those applications in your computer are stored in your RAM, and as soon as you close your application, that will be deleted from your RAM. So here memory just means it will be stored temporarily for the sake of this function call. And we are also going to go in depth in the storage locations later. Okay. But for now, just know that it is for the sake of this function call. We are not storing anything in these strings forever. Okay. So we are not changing anything, right? Now let's say tomorrow I change the value of this poet, like I change this to something else, and at that time this string will return something else, because that will be for the sake of this function call only, right? The next time we call this function, it will be a new value which it will take from these values. Okay. If anyone has any questions, they can ask. I totally understand it can be confusing, and also I'm not at all doing a good job at explaining this.
I just wanted to add something. Um,
Yeah.
if you go back to your browser. Um, yeah, so if the memory thing confuses you, just know that you need it, okay? For now, don't go too much into like the depth of how it's stored on the hardware and all that. Just think that you need it if you're, assigning a string variable. Simple as that. And then later on, when you get more advanced, you'll understand how it's stored on on your local memory and all that. So for the time being, just know that you need it there. And
Yeah.
yeah, if has any other questions, go ahead. Sahil and LJ will probably answer.
So
Well,
yeah.
I
So
just wanna say one thing
yeah.
too. All this don't get too advanced, but the reason usually when you return a value like a UN, like a number, usually you don't have to put that memory. But string is a special case because um storing strings and Solidity and the blockchain, it is very, very expensive. And you can't do that with like NFTs. Not gonna go deep into that, but I just want to point that out.
Yeah, because strings do not have a specific size, right? We can specify a string for as long as we want, right? It can be it can be infinitely long. So Solidity does not know in advance how long this string is going to be. That's why it needs to know where it's going to store that string. But for uints or ints, it is predefined that they can be only like we have types like uint 256. So it is predefined that it is only going to be at max 256 bytes long, right? So Solidity knows that it can be only 256 bytes long, but we do not have anything for strings. They can be arbitrarily long. So that's why it needs to know where it is going to store them. That is the reason. Okay, so let's come to a compiler
You
and
starting to
compile
break
this
up a little
file,
bit.
right?
You lagged a little. Um, it shows
Is
the bar. Yeah, you're lagging like a lot.
Should we go to another programming or?
No. Just go. Can you go to? It says the bar is on red.
Okay, let me share it again.
Let me try.
Is it fine now, Abbas?
Your voice is fine.
There is the red bar there.
Your ping shows high. I don't know.
Yeah, it is very high. Actually, in this pair programming channel, it is very high for me. That's why I always join this one. In this pair programming, it is fine for me.
Let me see. I don't know. Should we drag and drop again or something?
Yeah, let's do this. I am going to another pair programming.
Okay. I'm gonna wait for a couple of minutes because it takes a while to connect the RPC on Discord. And then, okay, I'll start. If you guys can join by yourself, do that. I just dragged the entire pair program. Yeah. Is
Yeah,
it
now it is
better?
fine for me. Yes.
You can share your screen.
Now it's like 73 milliseconds. Okay. When I share my screen.
Yeah, you're
But I guess
lagging.
it is fine for you now. Again.
Your voice is still a little laggy. Can you guys see a screen?
Yep, I saw it, but now it's gone.
Yeah, yeah. I was able to see it too.
Yeah, it's visible now, Sahil.
Yes.
Yeah, it's at 5 FPS.
Alright, I think you should be good now.
Should we continue?
Oh.
Okay.
At times,
So
Discord
I have
also.
compiled this file. Yeah. Now let's deploy this. Okay. Were you saying anything about?
No, I said go ahead, but I said it a very long time ago, and it turns out you heard it now.
Okay, let's deploy this contract. As you can see, it is deployed. Okay, and when I click on get details, then you can see it gives me these strings. You can see the void one. I am silent. I wrote this one on 22nd of March 2022, and this another string, which is our poem. Okay, so now you might ask, but Sahil, this will be gone as soon as you will close this tab, right? How is it going to act as a proof of ownership? Or how will I prove to the world that yes, it was me who wrote this poem? Yeah, so that's a good question. For that, right now we have deployed it on JavaScript VM, which is not the actual blockchain, but we can deploy it on the mainnet or on the testnet. So, what are mainnets and testnets? So, mainnet is the actual Ethereum blockchain, right? And testnets are just duplicates of that mainnet. And so they are like the real mainnet, but except we have fake ether there, and we can do all the stuff which we can do with mainnet. So let's deploy it on a test net, right? For deploying it on a test net, we have to select injected Web3 here, the injected Web3 option for our environment. So I have selected that, and as soon as I click here, it pops up my MetaMask, and it will ask me to okay. So now you can see it is connected, right? And I have selected Rinky by testnet, so I am going to deploy this contract on Rinky by testnet. It is it is same as the mainnet, but just it's going to be fade ETH, right? So I will come here and I will deploy my contract on Rinky by testnet. So when I click deploy, it's going to again pop up my MetaMask. Why is it going to do that? Because it is we are going to create a smart contract that is an actual transaction. We are going to append something to the actual blockchain. So that's why it will ask it will ask me to pay some ether. Um, I don't know why it is not popping up my MetaMask now.
Is the transaction still pending on MetaMask?
I don't know. It's not even popping my MetaMask right now. Okay, there it is. Took some time. All right. So just gonna reject this one because I clicked it many times. So here it is. Now we are going to create a smart contract, right? Make sure you have some Rinky by Ether. You can go to okay. So I just confirmed my transaction, all right, and it's gonna take some time because it will be included in the next block, and that's approximation time is 15 seconds. Okay, so it is confirmed as you can see. So now we will go to Etherscan to view our transaction. Now here we are on Etherscan. It says this transaction has been included and will be reflected in a short while. So let's just wait for it to be included in a block.
Fine.
Yes.
Fine. I have some test Ethereums in my Repston networks. Can you
Yeah,
redo that thing again?
you
How do
can.
we go again?
Okay. So you select injected Web3 here in the deploy tab,
Done.
injected, and also make sure to select Robston. You have Robston, right?
Yep.
So make sure to select Robston here instead of Rinky by select Robston network here, and it
Okay.
will be connected to your remix, and it will show Robston here instead of Rinky by.
Okay then.
Then you just click deploy, and it will pop up your MetaMask.
Okay. No, like how can I will click here like view on Etherscan, then it will open.
Yeah, it will open Etherscan just like
Okay.
this.
Thanks.
So you can see this transaction was successful, right? This is our transaction hash, and the status is success. It was included in this block. This is the block number, right? So it is 10,103,000, right? So it was included in this block, and it was 1 minute ago. It also tells you the time, right? 22nd March 2022, and this is the time in UTC.